Welcome to Vedavyasa Academy. Here in this session we discussing about the solution of the equation by Gauss-Jordan method. Here we have completed the solution of equations by Cramer's rule, solution of equations by inverse method completed. These are the 7 marks question, Cramer's rule and inverse method, Gauss-Jordan method. These are the 7 marks problems by for IP. So this is the problem given. 3x plus 4y plus 5z is equal to 18. 2x minus y plus 8z is equal to 13. 5x minus 2y plus 7z is equal to 20. Solution of the equation by Gauss-Jordan method. So first you have to write these equation into matrix form. 3, 4, 5 and 2 minus 1, 8. 5 minus 2, 7 is into x, y, z is equal to, this is 18, 13, 20. This is the variable matrix. This is the coefficient matrix. This is the variable matrix. This is the constant matrix. Ax is equal to D. Then you have to write augmented matrix. Augmented matrix. Augmented matrix. Augmented matrix AD is equal to matrix 3, 4, 5, 18 and 2 minus 1, 8, 13 and 5 minus 2, 7, 20. This matrix by the operation you change into like this: 1 0 0 0 1 0 0 0 1 x y z. Our job is you can transform this matrix into like this. Then these values are x y z. That x y z are the solutions of the given matrix. Here need not to find the determinant. Here need not to find the determinant. Here we don't, you observe here it is this matrix singular matrix or non-singular matrix. We don't want here. It is singular, it is non-singular. You can find directly x, y, z values in the form of Gauss-Jordan method. Okay, all of you. In the case of Cramer's rule and inverse method, we want to that matrix should be non-singular matrix. That is data not equal to 0. Then after you can proceed. In this Gauss-Jordan method, we don't want whether it is singular, whether it is not singular. Okay, directly you can do this one. Okay, this is the augmented matrix. Augmented matrix, this is. So first our job is, you can, these two elements are 0. So these two elements are 0. So this element R1 implies, R2 implies 2R1. Sorry, this is R2 implies 3R2 minus 2R1. And R3 implies, this is 3R3 minus 5R1. Okay, all of you. Then augmented matrix changes to, this is first row element, or you write here, this is augmented matrix change into, augmented matrix change into This is first row 3, 4, 5, 8 same 3, 4, 5, 8. 18, sorry, 18 change. And R2, 3R2 minus 2R1. This is 0. 3R2, 6 minus 2R1, 6. 6 minus 6, 0. Next, you have to write this one. 3R2 minus 2R1. You observe here, this is 3 into minus 1. 3 into minus 1 minus 3 minus 2 into 8. 2 into 4, 8 is equal to minus 11. This is minus 11. And this one 3R2. 3 into 8, 24 minus 2 into R1. This is 10 equal to 14. This value is 14. Okay, all of you. Next, 3 into R2. 3 into R2. This value 3 into 30. 39 minus 2 into 18. 2 into 18, 36. This value 39 minus 36 is 3. Okay, all of you. R2 completed. Next, R3 elements. This value 0 and 3R3. 3 into minus 2 minus 6 and 5R1. 5 into R1. 5 into 4, 20 minus 20 minus 26. This value is minus 26. And 3 into R3. 3 into R3 is 21. 21 minus 5 into 5 minus 25 equal to minus 4. Okay, all of you. Here 3 into 7. 3 into 7. This one completed. 3 into 20. 60 minus 5 into R1. 5 into 18. 90 is equal to minus 30. This is minus 30 is there. Okay, all of you. So here you observe here you observe this augmented matrix. You observe this R3 has the 2. So R3 by minus 2 equal to R3 implies R3. So this is augmented matrix. You write again 3, 4, 5, 18. 0, minus 11, 43. 0, 13. Minus 26 by minus 2, 13. Minus 4 by minus 2, 2. And minus 30 by minus 2, 15. This is the augmented matrix, changed augmented matrix. Then after we have to do, you have to do perform these two elements as 0. That means these two elements are 0 with the base of R2. With the base of R2. So for these two you can write R1 implies. R1 implies. This is R1 implies 11 R1 plus 4 R2. Okay now? This will be 0. R2 implies 11 R3 sorry, this is 11 R3 plus this is 13 R2. Then we have to change augmented matrix as like this. This is R1 11 R1 11 into R1 3 plus 0. This is 33. This value is 0 and 11 into R1 5 55. 4 into R2 4 into R2 4 into R2 is 46. Sorry, 56. 56. Then 111. This is 111. Okay, all of you. Next, 11 into R1. 11 into 18. 11 into 18. That is 198. 198 plus 4 into R2. 4 into this is 12. 10, 1, 11, 1, 2, 10. Okay, all of it. This second row 0 minus 11, 14, 3. And third row. Third row is 11 into R3. This is 0. And 11 into R3. This is 0. And 11 into R3. 11 into R3. This is 22. Plus 13 into R2, 13 into 14, 13 into 14, 13 into 14, 14 3 ja, 14 3 ja, 42, and 14 1 ja 14, 182 plus 22. This is 10, 8, 11, 2, 10. This is this is 2 plus 2, 4, 4. This is 10, 1, 204. This is 204. And this is also, you observe here, 11 into R3. 11 into 15. 15, 15. 5, 6, 165. 13 into 3. 39. 9, this is 14, 0, 1, 204. This is also 204. This is the augmented matrix. Okay, all of you. This one, you make these two are zeros. These two are zeros in this session. So, you have to write this as, augmented matrix. Augmented matrix is equal to here this is the third row, R3 by 204. 204 as common. Then augmented matrix, you write augmented matrix as 33, and also you write R1 implies R3, R1 implies, in this also 3 is the 3 is the common. So R1 implies R1 by 3. R1 by 3. Then what is the augmented matrix? 11, 0. This is 3 3 ja, 9, 21, 3 7 ja, 37. This is 70. This value 0, minus 11, 14, 3. This value 0, 0, 1, 1. Okay, all of you. Then after you have to this value 0, these two are zeros. So R1 implies here base is the R3. R1 implies 37, R1 minus 37 R3. R2 implies 14 is there. So R2 implies R2 minus 14 R3. Then what we will have? This is 11, 0, 37, this 0, 70 minus 37, 33. Okay, all of you. This is 0, minus 11, 14 minus 14 minus 14. This is 0, 14, this value 3, 3 minus 3 minus 14 minus 11. Minus 11, 0, 0, 1, 1. Okay, all of you. Here R1 implies R1 by 11. R2 implies R2 by minus 11. Then what is the matrix here? What is the matrix here? You write this matrix is here. This matrix will change into AD is equal to matrix, segmented matrix change into 1 0 0 3. So all R1 by 11 by 11 1 0 0 33 by 11 0 1 0 1 0 0 1 1. So this is equal to 1 0 0 x 0 1 0 y 0 0 1 this z. So by comparing these two matrices, x is equal to 3, y is equal to 1, z is equal to 1. These are the solutions of the given system of equations. The solutions of the given system of equations. Okay, all of you. That's all. This is the very important Gauss-Jordan method.